Hey everyone, welcome back. In today's video, we are diving into something that is super crucial in modern web applications, which is OAuth2. We will break down what OAuth is, why it is used, and its flows that make it all work. By the end of this video, you will have a solid understanding of core concepts behind OAuth. So let's get into it. In the early days of internet, sharing information between services was simple but risky. Suppose if you want to use the services of a website, let's name it as service A, but you do not want to create an account in that service. Instead, you want to use your already created account in another service. Let's name that other service as service B. That service B is having an auth server. So service B holds your details such as name and email ID, which is required for service A. So for that, you provide your credentials of service B to service A, and service A will directly log into service B using your credentials and access your information. This method was unsafe because number one, it puts your credentials at risk as you are giving your credentials to service A. And also there is no guarantee that service A would only access the required details from service B, as you do not have any control over what service A can access. To overcome these problems, OAuth was introduced. By following these standards, we don't need to share our credentials of service B to service A. It also allows us to control what data we want to share from one service to another service. Most importantly, we can also revoke the permission of any service whenever we want. Let us try to understand this with a very simple example. Suppose there is a website, wishit.com, which many people use to send wishes over the emails. And you also want to use this website to wish your friends and contacts of your Gmail account on the occasion of Diwali or New Year. Also, you do not want to create a new account in this website and want to make use of your Gmail account details only. Also, if you create a new account, then you also have to remember and manage its username and password, which you do not want to do. In this case, implementing OAuth will help you satisfy all your requirements. You will act as a resource owner because you are the owner of your email contact list. The application wishit.com, using which you want to send the wishes, will be the client and also will be requesting to access your data, which is the contact list from your Gmail account. Now let us see how the complete flow might work using OAuth. First, you open wishit.com and there it asks you to log in. But you are neither registered on this website nor you are planning to provide all your details to them, but still want to use their service. Then it presents you with an option of sign up or login via Google. You click on that and it takes you to Google login page. There you provide your Google login details and authenticate yourself. After that, you will be redirected to a permission page where you will decide if you want to give wishit.com access to your Google account details. In this, there will be an option to share the email contact list which wishit.com will be using to send the festival wishes. Once you approve this, wishit.com will be able to access your Google details which you have permitted. In this scenario, OAuth is working under the hood. Wishit.com will receive a temporary authorization code which it will use to get an access token from your email provider. OAuth2 is an open standard for access delegation. Delegation is the keyword here. It means the access related responsibilities are delegated to some other application instead of handling it in your own application. OAuth allows third-party applications to access user resources without sharing the user credentials. Like in our example, third-party application wishit.com accessed Gmail contact list of the user without handling any authentication or sharing the user credentials. This way, you don't need to create and remember username and password for every website. Plus, your credentials stay secure since they are not directly shared with the third-party website. In our example, we have already discussed the different roles, but let us just reiterate it in a formal way. There are 4 different roles in OAuth2. The first role is resource owner. It is you, the user, who owns the data. Data could be your Gmail profile or email. Another role is client. It is the application or website, which was wishit.com in our example, that wants to access your data like your email list. Third role is resource server. It is where your data is stored. In this case, Google server is where your complete profile detail is stored. The last role is authorization server. It is the system which verifies if the user is valid. In our example, it was Google that checks if you are really you by making you log into the Google system using username and password. And on successful authentication, it gives a token to the website to access the data you have permitted. Now, if you see, we have followed multiple steps in our example for completing the authentication and sharing the required information. That was one of the way to implement OAuth, but it is not the only way. OAuth support different flows based on different use cases. The most common flow is authorization code flow. This flow is used when you need to log into website through a third-party services like Google. It is mainly for server-side applications where security is a top priority. It also ensures that a website doesn't directly handle your username and password. Let us see step by step how this flow works. First, you click on Login with Google or any other service on the website. Then the website sends a request to the service you have picked, like Google Authorization Server. Then you are redirected to Google's login page, where first you log in and then shown a permission page. This page shows the data like your name and email that the website wants to access. Sometimes you can even choose which data you want to share. Once you approve the access, then Google sends an authorization code back to the website. Now the website sends that authorization code back to Google in exchange of access token. And finally, the website uses this access token to access your data, whichever you have permitted from the Google server. The key benefit of this flow is that your credentials, like your passwords, are never exposed to the website and the access token stays safe, making it very secure process. Now you might be thinking that why do we have this extra trip to get access token when we already have the authorization code with us? This extra step is added to make sure that only valid third-party application is trying to access the user data. Because the third-party application needs to send their client ID and secret along with the authorization code to get a valid access token. This verifies that the request comes from legitimate client. If an attacker somehow intercepts the authorization code, which is possible during the user browser interactions, they couldn't use it to access the resource directly because they wouldn't have the client's credentials, which was client ID and secret, because without these, they cannot exchange the authorization code for an access token. This reduces the risk of attacks such as man in the middle or code interception. The disadvantage of this extra trip is it adds an extra step which increases the response time. But this trade-off is considered worth it because the added security outweighs the minor overhead of that extra step. The authorization code flow was designed with security as the highest priority, especially for the sensitive data and services. Alright, let's talk about one more flow, the implicit flow. This one is mainly for single page applications. These applications are running entirely in your browser. They do not have a backend server to handle the usual step of exchanging authorization code. Now let us see how it works. At first, the client, which is your application, sends the user to authorization server. It can be Google, Facebook, or any other provider. Then the user login and gives permission to the application. Now here the flow becomes different from authorization code flow. In implicit flow, instead of getting an authorization code first, the client skips this step and gets the access token directly in the URL. Now the app can use this access token to access the user data from resource server. The main point here is that there is no code exchange. So you get the access token right away. But it is not much secure because token is exposed to the browser, making it more vulnerable to attacks. I hope till this point everything is clear to you. If not, you can rewatch the video and let me know in the comment section so that I can try to clear your doubts. Now, we have more flows supported in OAuth 2, but I'm not going to cover them all in this video because they consist of similar steps which we have already discussed in these first two flows. They are present just to implement specific use cases. Now I want you to go through this website from where you can learn about the remaining flows. These are very simple flows, and if you have understood the first two flows clearly, then understanding these should not be hard. On how to create an OAuth application using GitHub. I'll explain you the complete process in a way that no one has ever explained. I really hope you are not only watching the videos but also implementing and practicing the work we do. If not, I urge you to please do the same, because only watching videos or reading tutorials will not help you. We will discuss in depth each and every component we touch. So let's get into it. First, open your web browser and go to github.com. And if you do not have an account, it's free, you can create a new account. After that, log in using your username and password. Now we want to use GitHub as a provider which will serve as authentication server and resource server. To do that, we need to create an OAuth app in GitHub, which is the main topic for today's video. For that, first you need to go to settings by clicking on profile icon on top right corner. Now on the left side navigation panel, scroll down to the developer setting. This is the place where all OAuth apps will be available. Now click on OAuth apps to see more details. Here you can see I already have one application test created, but for today's video we will create a new application, and that same application we will use in our next video of Spring Boot implementation. Now to create a new one, click on New OAuth App. Here we have to provide few mandatory and few optional details. Let us understand each of these details. First one is application name. Let us continue the same example of wishit.com. Now the main question is, who is required or responsible of creating OAuth app in GitHub? Is it the resource owner, also known as user, or is it the client, which is wishit.com? It will be the client, that is wishit.com, because this website wants to delegate the authentication responsibility to GitHub instead of implementing on its own. So let us name our OAuth app as wishit.com. The next mandatory field is homepage URL. As for this demo, we will be running our application at local, so let us give the localhost URL with port number. The homepage URL is a publicly accessible URL that represents the main entry point of your application. By defining localhost as homepage URL, GitHub allows localhost URLs specifically for testing purposes, so you don't need to expose your development environment to the internet. You can test how users interact with your application's OAuth flow locally before deploying it publicly. In production environment, you should set the homepage URL to your publicly accessible domain. So for our local testing, let us provide localhost :8080 as homepage URL. Now moving ahead, next field is application description. Although this is an optional field, but it is always better to provide details under this field. Let me provide some sample text here. Moving to the next field, authorization callback URL. This is one of the most important detail in OAuth app. We will discuss this in detail. It is the URL where OAuth provider, which is GitHub in our case, will send user back after they have successfully authenticated and authorized. So what exactly is a callback URL? The callback URL is the endpoint in your application that receives the authorization code from OAuth provider. Once the user grants permission, GitHub redirects the user back to this URL along with an authorization code. Your application then exchanges this authorization code for an access token, which can be used to make authentication request on behalf of user. If you remember, this is the exact working of authorization code flow. But you know what is awesome in this case? We don't even have to create this callback endpoint in our application. This is the default OAuth2 callback endpoint for Spring Security's OAuth client. In our case, the provider will be replaced with GitHub. When you configure Spring Security to handle OAuth2 logins with GitHub, it expects GitHub to redirect back to this particular path. This endpoint is divided into two main parts. One is /login/OAuth2/code. This is the standard path Spring Security uses to handle OAuth2 authorization codes. And this will remain as it is even if we change the provider from GitHub to Google or Facebook. The second part is the name of the provider. This part indicates the provider that you are using for OAuth2. Based on provider names, it will find the client ID and secret details from your application.yaml or properties file. Let us try to understand why do we need to set this callback URL in GitHub. GitHub needs to know where to send the user after they approve your app. This is why this property is configured in OAuth app. If the callback URL doesn't match with what you have in your GitHub OAuth app configuration, GitHub will reject the OAuth flow with an error. Let us see how complete flow will work, and the same we will be implementing in our next video. First, we open wishit.com. We do not want to create an account in that particular website, but we want to reuse the details from some other provider. So we have an account in GitHub, and luckily Wishit.com has implemented OAuth2 in their website. There we have an option of login via GitHub. So we click on login via GitHub button. There we are redirected to GitHub's authorization page. There we provide our GitHub username and password and also approve Wishit.com to access my details from GitHub. After successful login, GitHub redirects us to the callback URL which is configured by Wishit.com's application with the authorization code. The callback endpoint is not explicitly defined in our controllers. Instead, Spring Security automatically handles it. Spring Security listens to the incoming request at /login/OAuth2/code/GitHub and processes the authorization code. Wishit.com then exchanges the authorization code using its client ID and secret for an access token from GitHub. After successful OAuth2 login and token exchange, Spring Security will redirect us to the page defined in our security configuration for successful login. It can be /home or /profile, whatever we have configured. I hope how this callback URL works is clear to you. In case you have any doubts, please let me know in the comment section. Now moving to the last configuration, which is an optional one, which is enable device flow. So in the last video, I have asked you to go through a website and understand about the remaining flows in OAuth2. If you have already done it, then you know what this option is for. If not, don't worry, let me explain it. The device flow is an OAuth authorization method designed specifically for the devices that do not have a web browser, such as TVs, gaming consoles, or IoT devices. When we enable device flow in our GitHub OAuth app, it allows users to authorize the app without requiring browser on their device. Instead, they can use another device like their phone or computer to complete the authentication process. Let us understand how this works. Suppose if we want to use GitHub account on our smart TV, for that authorization flow will be initiated from TV. It will display a unique code along with a URL like github.com/login/device. Then we open that provided URL on a phone or computer and enters that unique code and logs into github.com. After logging in, we can authorize the app on GitHub. This device will then receive authorization result, allowing the app to access users' GitHub account. In our case, we are not using this app to authorize any such device, so we will keep it unchecked. That's the only information we need to create an OAuth app in GitHub. Then just click on register application. It will navigate to the created application details page. Let us see what all details we have here and what all actions we can perform. The first information under General tab is ownership information. This tells us the GitHub username of owner of this application. There is also an option to transfer the ownership. If you want to assign some other user as owner of the application, that is also possible. Just click on the transfer ownership and provide the required details in pop-up. Next is you can list your application in GitHub Marketplace so that the users can discover it. As of now, this application is not discoverable. Next is the number of users and token issued under this application. It also gives an option to revoke the tokens that gives you more control. Then we have client ID, which will remain same what was generated during the application registration, and the corresponding client secret. As it is a fresh application registration, so for the first time we need to generate the secret. For that, click on generate a new client secret. Be very careful and note this secret down somewhere, because once you move out of this page, the secret will not be visible again. You can generate different secrets also and delete them if not required, but the condition is at least one secret should remain there after initial creation. Just below that, there is an option to upload an image which will be shown to the user along with your application name during authentication process. Below that, you can see all these configurations which we have already defined during the registration. So if any of the information like name URL, callback URL are required to be changed, that can be done from here. After making all the required changes, click on update application. Apart from the general setting, I can see there are two more options available. One is optional feature, which is not live yet in GitHub, and the second option is advanced option. In advanced option, there is only one action which you can do, which is to delete your application. So this was all about creating OAuth application in GitHub. You can also try to create OAuth app in GitHub, and the same can be used when you practice in parallel with me in our next video. I really hope you are not only watching the videos but also implementing and practicing the work we do. If not, I urge you to please do the same, because only watching videos or reading tutorials will not help you. We are going to implement OAuth2 in our Spring Boot application using GitHub as a provider. In previous video, we have already created one OAuth app in GitHub. If you have not yet created and wants to understand how to create it, please watch the previous video before continuing. We will demonstrate login via GitHub in this video and execute various scenarios to understand how it works. We will also see what happens if we revoke all the tokens. I have the application ready to save some time, so we will walk through every part of the application from the configuration files to HTML templates, explaining how they work together. I had started creating this application using simple command line. If you also want to create an empty Spring Boot application, you can simply open PowerShell in Windows and type in this command. Here we are invoking a web request to Spring Initializer and passing the name of the project, dependencies that we want, in our case which will be the web dependency, and the type of project, which is Maven in our case. The option of out file is used to save the output of web request in a specific file, like we are saving it in OAuth2 demo zip. To create a Spring Boot application using terminal in Mac OS or Linux, you can simply use curl command, which is commonly available in all Unix based systems. This command sends a request to Spring Initializer, similar to the PowerShell command, to generate the project with specific parameters. Now let's kick things off with pom.xml. Pom.xml is where our Maven project gets its configuration and dependencies. Under dependencies, we have added few key components. The first one is Spring Boot Starter Web Dependency. It brings in everything we need to build a web application. This will help us creating endpoints, managing model in controller classes. Another important dependency is Spring Boot Starter OAuth2 client. This dependency is essential for working with OAuth2. It provides the necessary tools to authenticate user through OAuth providers like GitHub. Like we had discussed about callback URL in our previous video, all that functionality will be provided in this particular starter dependency. Now we also want to have some front end which will interact with these endpoints and populate the model data. For that, we will be using a template engine, Spring Boot Starter Thymeleaf. It is the dependency which will allow us to render HTML templates. Other than that, we have also added some test dependencies and few web related dependencies for UI. Now let's move to the application.yaml. In this particular file, we configure our application related settings. In this file, we set up OAuth2 client configuration. We provide the client ID and client secret for our GitHub application, which we obtain from the GitHub developer settings. These details we had generated during the OAuth app creation in our previous video. That is why I was emphasizing on creating a GitHub application. If you still do not have created one, please pause the video and watch the previous video to create your own OAuth application using GitHub, so that you can use the client ID and secret generated in your application. We also specify the scope of the access. Here we are using read user, which allows us to read the basic user profile information. This simple configuration sets up our application to interact with GitHub securely. Now let us dive into the heart of our security setup, which is security config class. In this configuration class, we use @configuration and @enable security annotations to define our security behavior. The security filter chain bean we create is responsible for specifying which endpoints require authentication and which can be accessed without any authentication. In this, we permit the access of specific paths such as /login and /logout, and also allow access to some static resources like CSS and JavaScript files. This means user can navigate to these pages freely, while all other requires authentication. Next, we set up the OAuth2 login process. Here we specify our custom login page and the default success URL, where user will be redirected after a successful login. And if login fails, we redirect the user to an error page to inform them about the issue. For the logout process, we set up an endpoint that invalidates the user session and clears any authentication information, ensuring that users are fully logged out. Now let us look at the controller mycontroller.java, which handles our web request and user interactions. This class is annotated with @controller, indicating that it will serve as a Spring MVC controller. We have defined several methods that correspond to different endpoints of our application. Let us discuss them one by one. First is /home endpoint. It retrieves the authenticated user details using @authentication principal annotation to access the OAuth2 user object. If the user is authenticated and try to access /home, then this object of OAuth2 user will have user details similar to the principal in Spring Security. We extract the user attributes like their username, profile link, and repositories. This information is added to the model and passed to the home.html view. Second endpoint is /login. It first checks if the user is already authenticated and then redirect them to the home page. Otherwise, we are returning a login view. This check ensures users who are already logged in don't see the login page again. After login, we have also defined an endpoint to log out the user and clear the context. For that, we have /logout. It logs out the user and invalidates their session, returning them to the logout.html view. Now, it is possible that during login request processing, some error happened. So to handle that and display the error details in a consistent manner, we have another endpoint which is /error. It retrieves any error details and present them to the user, which is essential for diagnosing the issue. Now only the UI components are left. The first page users see when they attempt to log in is rendered by login.html. It contains a button that directs them to the GitHub authorization page. Upon successful login, users are redirected to home.html page. This page welcomes them and displays their GitHub username, profile link, and link to the list of their repositories. Now, after the user is done with their activities in the application and wants to log out, they can click on logout button available in home.html. After logging out, user lands on this page, which confirms that they have been successfully logged out. It provides a clear button to log in again, creating a smooth transition. In case something goes wrong during the login process, this page informs user that the error has occurred. It provides error details and link to go back to the login page. These templates work together to create a smooth user experience, guiding users through the authentication process. Now let us start our Spring Boot application and try to access /login endpoint. Now before I initiate the login, let me open my GitHub app as well. Here you can see the number of users is currently 0. We will demonstrate login via GitHub from some other account and then verify the number of users here. Also, we will test after the user permitted GitHub app the access. Then relogin will no longer require user to authorize the app again. It will directly get the user token. We will also see what happens if we revoke all the tokens. So let us begin with accessing /login. Here we have this login button which will initiate the login via GitHub. This will take us to the GitHub authentication page. If you are not logged in, then it will ask you for your username and password of GitHub. On successful authentication, it will open an authorization page where we can see the application wishit.com trying to access your profile details. This page also gives you the detail of who is the owner of wishit.com application and your GitHub username which wishit.com is trying to access. Now let us click on authorize button. It will send back the authorization code to the callback URL which our application internally exchanges for the access token. After all this, using the access token, our application will fetch user details and display on home page. This is the GitHub username of user who has permitted wishit.com to access the details. Then we have a hyperlink to GitHub profile. Let us click on this and open it in a new tab. So here you can see the profile page of GitHub user which is logged in. We have also printed a link to the repositories created by this user. If we access this link, it will give us a response in JSON format. Here you can see in our OAuth app, token is issued and permitted to 1 user. Earlier it was 0 users. Now let us test another scenario where we will first log out and try to log in again. On clicking logout button, it has navigated to the logout page. Now here, if I try to access /home page, it will not navigate to home page, rather it will redirect us to the login page because we have already invalidated the session and cleared the security context. Now let us try and log in again. Our expectation is it should not ask us again to authorize wishet.com because we have already authorized it previously. Here you can see clicking login via GitHub, we are directly redirected to our homepage after authenticating in the background. If I log out of github.com in the browser, it will just ask me to re-log in using my GitHub username and password, but will not require me to authorize wishet.com again. Now the last scenario, we have an option to revoke user access tokens in our OAuth application in GitHub. Let me revoke it and then try to re-log in. Now here you can see it is asking me again to authorize wishet.com to access my GitHub application. So this is how we have more control over who can access this functionality, which makes our application more manageable and secure. So that was the complete code and demo of OAuth implementation in our Spring Boot application using GitHub as a provider. In similar way, we can generate client ID and secrets from other providers like Google or Facebook. But the cool part is you do not have to change any logic implementation in your application. You just need to add the appropriate property in your YAML with the details. Now this complete code is available in my GitHub repository. I have already provided the link in description. You can go ahead and check it out. I hope this video was helpful. If you have learned something today, don't forget to like the video and subscribe to the channel. Also press the bell icon so that you won't miss any new video update. Your feedback is very important to me. Let me know if there are any shortcomings or how can I improve the content more. Let me know if you want me to cover any specific topic which is related to either Spring Security or any other technology. Please let me know all that detail in the comment section. Thank you so much for watching. I'll see you in the next video. Till then, happy coding.